Okay. Your final exam is going to be based on experiment 1. Experiment 1, 4 weeks of experiment 1. Then you have your experiment 2, which is kinetic. Basically, the type of questions that you have on the pre-lab assignment. That would be the type of questions that you see for the kinetic. And that is, if you double the concentration of compound 1, what happens to the rate of the reaction? So the question is this like if it's a first order or is the second order? So if you know if this is first order or second order, you double the concentration, the answer would be different. So for first order, you double the concentration, the rate would be double. If it's the second order, you double the concentration, is going to be quadrupled. So I do not include any calculations from the data sheet, but the simple like calculation from the pre-lab would be part of the exam. You have access to scientific calculator, so just make sure that you find the link when you open the test. There's a link for scientific calculator. The questions that you have from experiment 1, very similar questions to pre-lab and post-lab, but no exact same question. And I was actually working on the week 2, and I was changing. So basically, let's say if last time that I used the question, if you have silver ion in one test tube, and if you have copper ion in another test tube, how would you know you have a which one is copper, which one is silver? The answer is you add HCl. HCl would precipitate with Ag or silver, but it doesn't precipitate with Cl. The question that I changed to, for example, it was a combination of a silver and lead. How would you know you have silver or lead? The grade also is going to be higher because it's more challenging, because if it's silver and lead, both of them would react with HCl. If both of them reacts with HCl, you get precipitate, then you don't know which one is which. But after the precipitate forms, then you have to add hot water. The one that dissolves is lead. The one that doesn't dissolve is silver with the hot water. Now, if I was nicer and I asked you a question that there is a white precipitate, we don't know if it's a silver chloride or lead chloride, how do you know which one it is? In that case, you only use hot water. So you see that the questions, even though I don't have to change the actual question, but just changing the ion is a new question. So instead of using like silver and copper, I use lead and copper, or I use lead and silver. So that gives me like different set of questions. Even students who are in the same class, they get like one person would get the lead and copper, the other one would get silver and copper. The answer is the same, but at least it's not the same question. But the questions are very similar to the pre-lab and data sheet questions. To find the answers to those pre-lab data sheet questions, you read the ebook carefully. Because if you read the ebook carefully, you should be able, and if you know how to use the charts, you should be able to answer the questions in the pre-lab and the data sheet. You get questions based on the evidence base. For example, I said you have an unknown solution, you add the KSCN or potassium thiocyanate, and a red color appeared, and bloody red color, that means that you do have iron. And if I say, let's say an orange color appeared, or yellow color appeared, or brown color appeared, or something purple, different color appeared, that's not indication for the iron. So you have to basically read the experiment very carefully in order to be able to answer a question like that in the final exam. So you would have questions just like pre-lab questions: what reagent is used to distinguish? And then you are given like evidences. Here are the evidences, what ions are present and what ions are absent. One common mistake the students have, they try to just give the ones that they are present, and then they lose point for the ones that they didn't specify. If the question indicates clearly which ones are present, which ones are absent, you must say which ones are present and which ones are absent. You can't just say which ones are present because the question didn't ask which ones are present. So little details like that, it can hurt your grade. And that's why I want to make sure that to tell you about those details in the review, just to pay attention and read the question and follow the instruction. And to prepare, make sure you read the ebook carefully. Look what's going to happen if you add this. What's going to happen? You add something else. That was for experiment 1 and 2. So we talked about it. Experiment 4 is the Le Chatelier's principle. And it's just basically if you have a reaction of A plus B that gives C plus D, the questions on the pre-lab, those are good questions. I don't have to use the same questions because I can switch the questions. I wrote those questions myself. I can just switch them around. And instead of saying reducing A, I would just say I'm adding A, or I'm adding something to precipitate A, I'm adding noble gas. So you have to see you should be able to answer. If a chemical reaction is given to you and the color of the reactant and color of the product is given, so what color appears and what's the cause of that color to appear, you need to know the cause for that also. For experiment 6, which is the acid base or the analysis of a weak acid, basically what you're trying to do is find the Ka for the acid. To find the Ka for the acid, your first step is to plot the graph. That's why you do titration and you record all those numbers, that is milliliter of the base added versus the pH. First step would be to plot the graph. When you have the graph, then be able to use the graph. I have 2 recordings. One is like a pre-lab for experiment 6 recording that explain exactly where to find the equivalence point, how to find half equivalence point, and what does it mean, the pH at half equivalence point, that's the pKa. You take the anti-log of that to get the Ka value. And then there's another recording just for finding Ka from the graph. That's 2. The book covers, it gives you the picture. The picture that you have in the book with the graph, it clearly shows where is the equivalence point. When you have like a big jump in the graph, is a big jump in the pH in the graph. And then volume of the equivalence point, you divide by 2 to get the half volume for the equivalence. And when you have that, you would find your next step would be to find the pH at that volume, and with the pH being equal to pKa at the half equivalence point, you can find the Ka value. To plot the graph, if you have any questions, you can search, Google, look for videos. Why I don't go over like step by step, you draw the x-axis, y-axis, and then you would scale and you would put your numbers like for manual graphing, because that is part of 1045 competency. We do have at least 2 experiments to plot graph in the in experiment for the 1045 lab course, and that is a prerequisite for this for 1046. I also included plotting the graph part of the using like a program using the Excel in the introduction portion of the lab manual. So just before you start with experiment 1, group 1 and 2 known samples, or experiment 1, a few pages prior to that, it shows how to plot the graph. In case if there is a still question, which I doubt at this point anybody would have question how to plot the graph, but in case if that is the question. So when you have the graph, you should be able to extract data from the graph. Experiment 9, which is the experiment for today, is talking about oxidation reduction, anode, cathode. So you need to know that what happens in cathode is reduction. That means gain of electron. So if copper gains electron, is going to go from copper 2+ to copper 0. If it's reduction, it happens in cathode. Oxidation will happen in anode. So oxidation happens in anode, reduction happens in cathode. A sample for oxidation, let's say if you have a zinc is going to lose electron, we change to zinc 2+, oxidation number has increased, electron is lost, and that is known as oxidation. If element loses electron, is being oxidized, but by losing electron, helping something else to be reduced, so it's also known as reducing agent. What is being oxidized is acting as reducing agent, and vice versa. What's being reduced is acting as oxidizing agent. So from experiment 9, you should be able to, I just looked at the video that is posted for the pre-lab discussions. It goes over detailed step by step in the pages of the experiment 9. And since you're doing only part C, for each reaction, you have basically 4 or 5 reactions. And for each reaction, you have 2 choices, which one is being oxidized, which one is being reduced. So if you have 2 choices, then you look for evidences. What happened? How do you know that water is being reduced, or let's say sodium is being reduced? So now, if water is being reduced, it's going to create or generate hydroxide ion, and it generates hydroxide ion. It makes that portion of the solution like basic, and if it's basic, it's going to change the color of phenolphthalein from colorless to pink color. So you are looking for evidence for the reaction. Your question has, I have changed some of those questions. Okay, I did change. I made 11 multiple choice questions and 9 short answers. I was working on another question to replace with, or I might just add another multiple choice question. So you're looking for like a 12 multiple choice questions and between 8 to 10 short answer questions. As I was changing out, I was also thinking to give you more, couple extra multiple choice questions. The free response questions, you have to give the answer properly. Don't just say, okay, the is not going to be, accurate. The result will be, inaccurate or not precise or messed up. Any of those comments is like general answer. It doesn't give you a specific point to it, because I don't know what actually you mean that is going to happen. And since you are not there to talk to me what you meant, I'm only grading the paper. You have to be careful with answering the question. Make sure it's evidence-based. And if it's calculation, is easy. Only simple calculation. I'm not using the calculation for complicated calculation, or basically is not a heavy in calculation part. The exam is simple calculation plus concept. So you need to know the concept very well. I think that's it. And for how you study for the exam, and good luck on your final exam. If you have any questions, you let me know.